Last time we used trigonometry to figure out side lengths. So let's say this is 20 and this is x. According to SOHCAHTOA, which trig ratio are we going to use? Well, what is the name of the side that's length 20? Oh, it's the opposite. Good. What about the x? H. Hey, you guys get this. So which one uses O and H? Sine. Sine of 30 is 20 over x. Is this a multiply or a switch problem? So we switch places with those, and we get x equals 20 over the sine of 30. So we plug that into our calculator. 20 divided by the sine of 30 is going to be 40. All right, we're going to do something a little bit different today. What if I had a right triangle and I called this angle theta, and I said this is 4 and this is 7. And I asked you, how big is the angle? If we write this out, which ratio are we going to choose? Sine, cosine, or tangent? What is 4? That would be the O. And 7 is the A. Which one uses O and A? O and A. Tangent. Tangent. I will write this out. The tangent of theta is 4 over 7. The tangent of theta is 4 over 7. All trig ratios take this, which is an angle, and convert it into this, which is a ratio. Okay, so it's 4 over 7. The ratio is 0.57. Okay, so whenever you have an angle this big, the ratio is going to be 0.47. What if I drew a smaller triangle that had 0.4 and 0.7? What's the ratio going to be? The same, 0.57. What if I had a huge triangle and it was 40 and 70? Well, each one of those has the same angle. Whatever this measure is, every single time you have a right triangle with that angle, the tangent will always equal 0.57 every single time. So, if we know what the angle is, we can use that information to find a missing side length. But if we know what the ratio is, we should be able to find the angle. I want to invert these. Tangent takes an angle and spits out a ratio. There's another function called the inverse tangent, and it does the opposite. And the inverse tangent, or tangent inverse, looks like that. Tangent inverse. So the tangent inverse of 4 over 7 should tell me the angle I'm looking for. If you look at your calculators, right above the tangent, you see tangent to the -1. So tangent inverse of 4 over 7 gives me 29.7 degrees. Every single time you have a right triangle where theta is 29.7 degrees, the ratio of the O divided by the A is going to be equal to 4 over 7. Okay? All right, let's look at one of your problems. Oh, I didn't pull it over, sorry. Here we want to figure out how large angle X is. Which trig ratio are we going to choose? Cosine. 4 is the adjacent side and 9 is the hypotenuse. So we're going to use the cosine. The cosine of angle X is 4 over 9. I need to use the inverse. Cosine inverse of 4 over 9 will tell me how big X is. Pull up my calculator. Cosine inverse of 4/9 gives me 63.6 degrees, and it wants to round to the nearest 10. All right. Do you want to see another one of those? Yeah? Can do. Which ratio will we choose here? Cosine again. 16 is the adjacent side and 25 is the hypotenuse. The cosine of X is 16 over 25. Whenever you are using an angle, you use sine, cosine, and tangent. Whenever you are looking for an angle, you use sine inverse, cosine inverse, and tangent inverse. So the cosine inverse of 16 over 25 is equal to angle X. Cosine inverse of 16 over 25 gives me an angle of 50 degrees. Okay, here I want to know how big the tangent is. So the tangent is the O side divided by the A side, but I don't know what the O side is. So I need to use the Pythagorean theorem to find it. X squared plus 8 squared equals 17 squared. So X squared is 17 squared minus 8 squared. 17 squared minus 8 squared is 225. What do I do with 225? Let's take the square root. Oh. And I get, oh, I'll get it. You guys just wait. There we go, 15. So this is 15. So I go over here and I write in 15. What is the tangent of theta? Well, tangent is O divided by A, so it is 15 over 8. Okay. What if this was the square root of 3? And I ended up with 15 over the square root of 3. What do I need to do there? Simplify. How do I simplify? You're not allowed to leave a square root in the denominator. So I times the bottom by root 3, which means I need to times the top by root 3. And the top becomes 15 root 3, and the bottom becomes 3. Can I cancel those 3's? No. Can I cancel a 3 out of those? Yes. So we pull out a 3, and I get 5 root 3, like that. Let's see how many we've done. 1, 2, 3, 4, 5. This is the same sort of problem. Oh, nope, we are not doing this one. Okay. not doing that one. Okay. So here, the instructions say solve the triangle, which means find everything. Find all the angles, find all the sides. So the angle is easy. How big is that angle going to be? If we have a right angle and a 50, then the last one's going to be 40. So angle A is 40. That was easy. All right. Let's choose this as my theta. What trig ratio uses C and 15? Cosine. The cosine of 50 equals C over 15. Is that a multiply or a switch? Multiply. So the answer is 15 cosine 50. $9.64. Okay. Now I need to find angle B. Here's where I would be a little bit careful. I could do, oh, I did that wrong, didn't I? C is the hypotenuse. Wow, I apologize, guys. So the cosine of 50 is 15 over C. Go ahead and correct me next time I make the huge mistake. Is that a multiply or a switch? It's a switch. So C equals 15 over the cosine of 50. How did I know my answer was wrong? Can this be 9.64? Can the longest side be 9.64? No, why not? It's the longest side, and the other one's 15, so I knew I made a mistake. Okay. 15 over the cosine of 50 is 23.3. That sounds better. Okay. I could use the sine. I could say the sine of 50 is b over 23.3. However, this number has been rounded. And a number that has been rounded could create an answer that is far enough off that Alex gets mad and marks it wrong. So either put lots of decimals here, 23.3358, that should be enough. Or I could use this ratio. Which one is going to use b and 15? Tangent. So the tangent of 50 is b over 15. Is that a multiply or a switch? Multiply. We just multiply by 15, and my answer is 15 tangent of 50. All right. What if I had this triangle? Let's call this A, B, so this would be little a. Here I need to find all of the angles and all of the sides. How would I figure out this angle? Which trig ratio is going to use 6 and 11? Cosine. The cosine of angle A is 6 over 11. What do I do here? What do we do when we want to find an angle? We invert. So cosine will take an angle and give you a ratio. The inverse will take a ratio and give you an angle. So we invert this and get cosine inverse of 6 over 11 is angle A. So cosine inverse of 6 over 11 is 56.94. So this is 56.94. How will I find angle B? You don't have to. So how do we find angle B? So we take 180 minus 90 minus 56.94, and I get 33.06. How else could I have got that? If we're looking at angle B, which trig ratio is going to use those? Sine. The sine inverse of 6 over 11 should tell me angle B. Sine inverse of 6 over 11, that is not an 11, is 33.05, which is what I got here. Okay. How do I find side A? There are lots of ways to find A. How could we find A? Well, we could use the Pythagorean theorem. We could say A squared plus 6 squared equals 11 squared. Or we know this angle. We could say the sine of angle A is side A. Oh, the sine of 56.94 is A over 11, and just multiply by 11. There are lots and lots of options to find side A. All right, let's look. Um, you know what? We're going to do this last problem. In a right triangle, how do we find the area of the triangle? Well, the area is 1/2 base times height. And in a right triangle, one of the legs is always the base and one of the legs is always the height. So in this case, it would be 1/2 x times 13. So I need to find the length of x in order to find the area of this triangle. Which trig ratio is going to use those? Not sine. What is the x side? It is tangent. So x is the opposite and 13 is the adjacent. So the tangent of 51 is x over 13. Is that a multiply or a switch? Multiply. So 13 tangent of 51 gives me 16.05. Okay, and notice it says do not round any intermediate computations. So you need to use a lot of decimal points. That's probably enough. So the area is 1/2 times 16.05366 times 13. Now, if you're lazy like me, there's a really easy way to do this in your calculator. 1/2 times, how do I get all of that decimal without writing it down? Just do second answer. So look at the negative key down below the 3. There's a little blue ANS for answer. If I push second negative, that tells me use my last answer in this calculation. And then I need to times that by 13. That is the area of the triangle. Do you need to see another one? Yeah? All right. Okay, let's do is the area of this triangle? Well, which ratio do I need to use to find x? This is the O side, and this is the A side tangent. So the tangent of 21 is 5 over x. Is that a multiply or a switch? That's a switch. So 5 divided by the tangent of 21 is 13.02. So my area formula is 1/2 times 13.02 times 5. And these are always legs. Notice I totally ignored the hypotenuse. So 1/2 times the answer times 5. 32.56. Do you guys know why the area of a triangle formula works? Why is the area of a triangle 1/2 base times height? Half a square or a rectangle, right? If I had a rectangle or a square, this area is base times height. So any triangle that is built using the vertices of that rectangle is going to be half that big. So in our figure here, oh, that didn't work. So the area of the rectangle is x times 13. So the area of the triangle is just half of that. All right. Work on 4.5. Good luck.